let's try to see how to draw the graph of this function. So first of all, y equals x plus 1, that's a simple graph to draw. Y equals x plus 1 has 1 as its y-intercept. What's the x-intercept of y equals x plus 1? Setting x plus 1 equal to 0, you get x equal to negative 1, right? So negative 1 is the x-intercept. If you have the y-intercept and x-intercept of a linear function, the graph is aligned, therefore all you have to do is just connect them. That's the graph. How do you draw the graph of y equals to 3 minus x? Well, if you plug in 0, you get 3, so I know that the y-intercept is 3. And also, if you plug in 3, you get 0, so I know that x-intercept is 3. So the graph is like this. Another thing that you could do is you can just read from here, this is negative 1 slope with y-intercept 3. So you can start with the y-intercept 3, and rise over 1 is negative 1, so you go down by 1 and you run by 1 to get to the next one, next one, next one, and then so on and so on. Okay? So that's the graph. All right. Now at 2, however, there's this place at 2 where the two graphs are different. Different graphs are used. Before 2, which one do I use? Do I use the one going up or one going down? Before 2. One going up. Only this is valid up till 2, right? This going down graph is not valid after 2. So I erase that up till 2. And then after 2, what happens? Only the one going down is valid and one going up is invalid, right? So that you have a graph that's not connected. Now at 2, if you plug into, where do you plug in? Do you plug in here or there? First one or second one? When you want to plug it. When you plug in 2, you get 3. So 2 comma 3 is an actual value. Now let's think about what happens if you plug in like 2.5, 2.3, 2.1, and so on and so on. Anything that's slightly above 2 will follow this graph. So all the values you plug in just after 2 will be following this graph right before it's actually 2. So what happens is that you have this graph, but the graph disappears right above 2. And you put an open circle there because it's disappearing. Okay? So this open circle means that the graph gets closer and closer to that point, but that actual value is not part of the graph because you only take the one that's bigger than 2. Okay? Get it? Okay. And here, we use the closed circle. This one's called the closed circle. And we call this an open circle. Just like when we wrote down we solved the inequalities and we used the open and closed to say it's part of the interval or not part of the interval. It's the same concept, right? We say it's a part of the graph, and this is not part of the